Welcome, Kaylee. Nice to see you. Okay, so day 2 is going to go fast. I'm only going to cover 12 slides, and I'm going to do them fairly quickly. Sorry, somebody was talking? Is that you, Kaylee? Somebody's talking. Okay. So let's start with the easy stuff, the x and y intercepts. You've seen these before. Oh, no, let's start with functions. It has to pass the vertical line test. So this one does. Let me get my handy dandy vertical line. So the red bar is my vertical line, and as I slide across the graph, it never touches more than one point at any given time. So yes, this one is a function. All right, let's do this one. How about this one? Is this a function?
No.
No. All right, let's do this one. Is this one a function?
No.
No. Let's do, let's see who just came in. Jess, hi. Jessica, can you hear me?
Yeah, I can hear you.
Okay, I accidentally threw you out last time. So I know that when I went to admit, I hit the remove button and I was hoping you'd come back in and you didn't, but I know you tried to get in last time. So I apologize. That was all on me, not you.
Okay.
Okay, how about this guy? Is this one a function?
Yes.
Yes.
Yeah. And then how about this last guy? Is he a function?
No.
No.
No. All right, so we need to remember how the vertical line test works. Super easy, not at all hard. Okay, now we're going to talk x and y intercepts. So when we do x-intercepts, you look for any place the graph crosses the x-axis. And you can see it crosses at -2. And I want it as an ordered pair, so I wrote the -2, 0. So when you go to your formative this time, you need to put it in ordered pair form and make sure your 0 for x-intercepts is in the y spot.
Do we have to put the parentheses too?
Yeah, it has to look, so when you guys do formative, they need everything to be lined up as exact as possible. So if you forget the parentheses, it's going to say it's wrong. If you forget the negative on the 2, it's going to be wrong. If you forget the 0 or the comma, so all of it has to be as close to possible. I think I have it saying accept answers that are partially correct, but I think it needs to be really close to right. All right, and then of course the y-intercept is right here where it crosses the y-axis at 1, and this time you put the 0 in the x spot and the 1 here. So who knows this x-intercept?
-3, 0.
Good, and then what's the other x-intercept?
1, 0.
Yeah. And then how about the y-intercept?
0, 3.
Okay, good. All right. And then this one is very confusing because look, it starts here at -5 and slides all the way to -2 before it lifts up. So every single spot in between is an x-intercept. So I just wrote there's an infinite number of x-intercepts between -5 and -2. You couldn't just say -5, -4, -3, and -2 because all the in-between points are also x-intercepts. And then is there another x-intercept or are we done?
There's another one.
3.
3, 0.
Yeah, exactly at 3, 0. And what about your y-intercept?
4.
Correct.
0, 4.
So 0, 4, right. You got to get it right. You got to put them in the right order. It's got too much space there. Okay, and then on this graph, what is my x-intercept?
You don't have one.
You don't have one. Good. Sorry, that's the y-intercept. And then the y-intercept is at 0, 1. So the x-intercept doesn't exist because an open bubble means there's no actual point here. Okay? So that's x and y-intercepts, and we're going to move forward. They're also, remember your x-intercepts are called zeros, roots, and solutions. The y-intercepts are not, but the x-intercepts are called zeros, roots, and solutions. Just thought I'd throw that in. Domains and ranges. Okay, so for this graph, you're going to notice some of these graphs are the exact same graphs that we've been using all throughout. So for this graph, it follows, if I follow this arrow, I'm going infinitely to the left. And if I follow this arrow, I'm going infinitely to the right. So this is my domain. It goes forever left. Say it again. So what's a way we could say infinitely left and infinitely right? I hear somebody talking, but I'm getting the echo. You know what? I'm gonna mute everybody because I think what's happening is Let me mute everybody. Unmute all. Mute all. Okay. All right. So I'm just going to rip through these real quick. If you guys have anything to say, you can put it in the chat box. Let me see if my chat is open. So will we put any? Yeah. So Gabby, for that, you could say infinite between 0.1 and 0.2, but I don't think I have one of these on the Go formative. So I think it would be too hard for you guys to write this. So there isn't any on the Go formative that has that. Okay. So domain, all real, because they go forever left and right. And then range is also going to go forever up and forever down. So we would say all real there as well. So let's see if I can do this. Yep. So the range is also all real. Same here. And then you can say all reals, or you can say from negative to positive infinity. Both of these work. So this one goes forever to the left and forever to the right and forever down and forever up. Notice at the 1, it appears there's a break, but as long as there's at least some value at the 1, we can say it is continuous between the negative and positive infinity. So this works for both graphs. Why isn't it coming? Oh, because it's locked. All right, so let me do this. Okay, now on this one, you can tell there's nothing in between the 1 and the 2. So it does have a point at 1, but it does not have a point at 2. So if you guys remember, we did function notation where we used brackets to say that the point exists, and then we used parentheses to say the point doesn't exist. So for this one, there's no arrows on this entire graph. So I would say bracket -5 for domain, all the way up to 1, and you would continue to have a bracket. But then you also have a parenthesis at 2 and then a bracket at 5. And that U means the union of, it means this and this make up the domain. Do you guys recall that? Give me a thumbs up if you remember. Okay. Jess, I can't see you because your video's off. And Kaylee, your head is in the bottom corner of your screen. I didn't see your thumb. No? You don't understand that? All right, I'll go over it one more time. So what we did is on these graphs, we said if there is a value here, and remember, nothing goes beyond. If there's a value here, you put a bracket and you say that point starts at 5 because 5 is included. And then the domain keeps going all the way over to 1 and it ends at 1. So we put a comma 1. And since the 1 has a point, we put a bracket instead of a parenthesis. That's my bracket. That's pretty bad. But then we jump from 1 to 2. So on the x-axis, there's nothing between the 1 and the 2. So at 2, we pick up again. But since 2 is not included, we have to put a parenthesis. Okay? And then that bubble means parenthesis. But then I go back up to 5. I continue going up to 5. So 5 is actually a point on the graph, the x value of 5. So we put a bracket. And then this U just means include this and this portion of the x-axis for your domain. Is that better? Okay. Now here again, for the domain, we're going to go forever left and forever right, and there is a point at 0, so we can say all reals from negative to positive infinity. For the range, notice there's missing points between the 0 and the 1. So for the range, you're going from the bottom up to 0, but I won't include 0, so I'll say negative infinity to 0. Remember, we always put parentheses on the infinities. We never put brackets because theoretically you can never reach infinity or negative infinity. And then for this part, we say pick out the 1 and we start with a bracket and we go to infinity and you always put parentheses on the infinities. Okay, can I get a thumbs up for everybody if you're good on this, or if you, no thumb for Karan or Jess? Okay, all right. Karan, do I need to go on or are you good? Okay, okay. All right, we're almost there, guys. Okay, the evaluate is you just look for the y value. So let's go back to this graph. You've seen it before. if I say find f of -3, I'm targeting in on the -3 on the x-axis. So here's -3. And I read the graph's y value. So this -3 value is here, and the y value is -1. All right, f of -2, I'm at -2 on the x-axis, and so the value for that point is a y of 0. F of 0, here's 0 on the x-axis. I read the graph's y value, and it looks like it's 1. F of 1, here's 1 on the x-axis. I go to the graph, and I find its point's y value. Again, that's also 1. And f of 2, here's 2 on the x-axis. So I go up to the graph and find the y value, and I get 4. Are you good? Okay, so in the chat room, everybody chat, what is f of -3 on this graph? Yep, here's -3, and the y value for this point is 0. How about f of -1? What's the y value for that point? Yep. Okay, how about f of 0 on this graph? What's the y value? Correct. And then f of 1, that's the trick question here. What's the y value for the f of 1? Okay, here's the 1 on the x-axis. Which one of these 2 points counts? This one or this one? Lee says it's the 0. Kaylee Archer says it's the 0. Yep, you guys are all right. All right, so let's get to, let's do the hard one on this one. What is f of 2? No. Silence in the chat room. What do you guys think f of 2 is? Yes, Gabby, correct. It is undefined. Right, because if you have the x value at 2 has a y value of an open bubble, which means I can't count this one. I have to say it's undefined. There's no actual point on the graph for an f of 2. How about f of 0 on this graph? What is f of 0? Yep. So f of 0, because there's an open circle here but a closed circle here, I actually do have a value, a y value for this point here that has an x value of 0. There is no point here, but there is a point here. So f of 0 is actually 1. All right, how are we doing? Can I move off this slide? I got a thumbs up, thumbs up. Jesse's drinking something. Gabby's thumbs up, okay. All right, guys. So the increasing and decreasing intervals. Okay, so what I have to say about increasing and decreasing is when you're looking for the interval, you always call out the x values. So this blue piece of the graph goes from -∞ to -1 on the x-axis. And what would you say that's doing? Increasing, decreasing, or is it constant as you go from -∞ to -1? Watch in my chat room. It's increasing, good. So I would put that in the increasing spot, good. All right, so from the red piece of the graph goes from a -1 on the x-axis to a +1 on the x-axis. So what is this piece of the graph doing? Increasing, decreasing, or okay, hardly even finished. And then the green part goes from 1 on the x-axis all the way up to infinity. And what is this piece doing? It's increasing, right? So that's just the sort for this first graph, okay? I'm gonna reset the page and we're gonna do the second graph. Okay, so this red piece of the graph goes from -∞ all the way up to 1, but it doesn't actually include 1. So what is the red piece doing on this graph? Ah, Interesting. Okay, so the red piece goes, you always read the graph as you go from left to right, like you read a book. So it's actually going up from the left to the right. So it is actually increasing. Well done, Karan. So the blue piece goes from 1 all the way out to infinity on the x-axis. So what is the blue piece doing? Increasing, decreasing, or constant? Correct, Kaylee. It is also increasing. Good. All right. So that's the sort for the second graph. I'm going to reset the slide and we're going to do the third graph. Okay, so the third graph, this red piece goes from, actually it doesn't go from negative infinity. It goes from -5 to +2, -2. Let me change that. -5 to +2. And so what is it doing? Yep, constant. Oops, let me grab this. It is staying constant. Then the blue piece, I had to break into 2 pieces. One piece goes from -2 to 0, and the other piece goes from 0 to 1. Where should I put the -2 to 0? What is that doing? Yep, that is doing the increase. What about the 0 to 1? It starts here and does, and then decreases, correct. So this piece decreases. And what about the 2 to infinity? Actually, that doesn't go to infinity either. That goes to 5. 2 to 5. What should we do with the 2 to 5? Decrease. So the sort for this graph has a constant piece, 2 decreasing pieces, and 1 increasing piece. And then let's look at the last graph. Let me reset the slide. Okay, let's reset. Oh, that's why, because if you reset it, it doesn't do this. Okay, so the last graph, from the -infinity to 0 piece, what should I do with this? I can't tell if you guys are increasing, correct? And what about the 0 to infinity? What should I do with that? Also increasing, correct? Okay, good. All right, so that's just how you break the graphs into its increasing and decreasing pieces. So that part will always be X interval values only. And then you call out what they do as you read it from the left to the right. Remember to read from left to right. Okay. All right, so any questions on increasing, decreasing? Okay, you guys good? Kaylee, are you good? Okay. All right, moving on. Max and mins. So a max is a relative max and a relative min. So if I said, just look at the piece of the graph here, you would say the maximum is right there at this point, whatever that is. And it's hard for me to read. It looks like it's somewhere between 0 and 1. And if I said, look at the graph over here, you would say the minimum is right at this point, right? So they're relative. They're not, the maximum of this graph is actually infinity because it looks like it's heading straight up, and the minimum is actually negative infinity because it looks like it's heading straight down. But what you're looking for is the relatives. So relative is just for a separate piece of the graph. If you were looking for, remember we called them hills and valleys, I think. So let me move this one off. And I would say, what is the max of this graph? What do you think the max of this graph is? 4, good. And what do you think the min of this graph is? -2, good. So the max is this point right up here, and you always read its y value. And the minimum is this lowest point down here, and again, its y value is -2. So that's max and mins. We are moving right along, guys. End behavior. Remember we called it up, down? So I would say down on the left and up on the right. Up, up. This one is leveling off, up. And then this one I'm not going to cover. But instead of saying the words down, we say that f of x, or the y values, approach negative infinity as x goes to negative infinity. So as x is traveling this way, if I'm watching my values go this way, my y values are going to negative infinity. And as x is going this way, my y values are going to positive infinity. So remember, end behavior is, and this arrow means approaches. So y approaches negative infinity on this side of the graph, and y approaches positive infinity on this side of the graph. And of course, y approaches positive on both sides of the graph. So you'll say y approaches positive as x goes positive and as x goes negative. And then here, this one is the one that's leveling off. So there's actually an asymptote on this graph right at the 0. I know I'm not doing, you know what? That's terrible. Let me see if I can do this. Nope, not that. This. So there's actually an asymptote right here. So y approaches 0 as you go out to the left of the graph. And you can see that right here. Y is approaching 0 as we go to negative infinity on the x-axis. And here, y is approaching positive infinity as we go to positive infinity on the x-axis. Okay? Are we okay with end behavior? Because end behavior sometimes gives us fits. Do we need to do 1 or 2 more? I think I have 1 more. I do. Okay, so for here, on this side of the graph, it does this weird thing, and then it levels off. So I'm saying y approaches 4 because there's an asymptote right here as you go to the negative infinity side. But on the positive infinity side of the x-axis, y approaches positive infinity because it's shooting straight up. If you guys want me to cover that more, now's the time to chat in the room or shake your head no so I can watch you. Okay. So Kaylee, are you okay? Okay, Jess, you too? Okay. And then asymptotes is the very last part of this whole slideshow. So asymptotes are what the graph is approaching. Just like that last graph with end behavior, you can see that this graph is sliding up and this one is sliding down, but they'll never actually have an x value of -5. So I can actually draw my dashed line in here and the graph never will touch it or cross it. Same over here at +5, and I just counted the ticks. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So my x asymptotes are at negative and +5, and then also there's a y asymptote here at 2. Notice this graph is going to slide alongside it and never touch it. You cannot say there's an asymptote at 0 because this is a peak, and then it starts to drop down. So it doesn't approach it. It goes up and then goes away from it again. So if it's not approaching it and sliding along it for a very long time, you can't call that an asymptote. Here they show you between 1 and 2, so x at 3/2 or 1.5, and here x at 3. And then you can also see there's a y asymptote at 0. They didn't draw that one in, but there is a y asymptote at 0. Let me pick that. So y asymptote at 0. Okay? Oh, I'm sorry, Karan, what did you want me to cover more? The end behavior or the asymptotes? Can you specify which one? I missed that chat. Never mind, you're good? Okay, good. So I hope that means I answered your question. All right, so that brings me to the end. This was a quick one. So we've got the formative key features of graphs, and there's a link in Google Classroom. Then there's a quizzes code in Google Classroom after you've done the formative. And don't forget, even though I see you twice a week, I see you Mondays and Wednesdays, I want everything due on Friday at midnight. Please, please, please make deadlines. I found that when they didn't let me set deadlines last marking period, nobody did anything. And Gabby's mom and I were talking, if you guys have some kind of a thing in your Google Classroom that says deadline, you tend to do it at the right times. But if I don't put a deadline, you won't do it. So let me just show you where everything is. You go to your classwork tab, that's where you should always be. The meet session is right here at the top, and this is your day 2 key features of graphs. There's the formative, there's your quizzes code, and this is awesome. I looked at this, and this is from MathBits. Let me see if I can find it. This is a really good review. I don't have any way of you sending it to me so I can grade it, but this asks you about x-intercepts, y-intercepts, increasing, decreasing, max and mins. I think this was a fantastic, so I put that link in Google Classroom too. And there's no way I can grade it, but if you don't do it, I think it's going to be sad because this is one of the best reviews of all parts of the graphs that I have ever seen. And then I'm going to post the notes for today, and I'm going to post the recorded video for those who didn't make it. So that should be it. I should not have to see you until Monday of next week. So does anybody have any questions for me? You don't think who was, Gabby? I didn't see that. Oh, the go formative. Okay, so yeah, I can do that. So this is what your go formative looks like. It's going to be, do you have anything in particular? Like there's a matching one where you have to drag the domain of the graph to the right thing. So this little thing right here is a grabber. Have you seen that, Karan? Okay, I don't know if you guys see it the same way I do, but I think this is student view. So I can actually drag this and put it on top of the right domain. So there's like a 3 matching domain, 3 matching range. You just grab and drag. And then this one is a drag and drop. So one of these graphs goes to negative and positive infinity on the x-axis, and some of the others go negative to positive infinity on the y-axis. So you drag and drop depending on whether the domain is all reals or the range is all reals, and you set it right in the box. And then let's see what else we have. Okay, so this one wants to know what are your x and y intercepts. So you actually put it in as an order pair. Start with the parentheses, put in the numbers, comma, number, close the parentheses, and then same down here. And it has to match as close to possible as you can get it. Same thing with here, that's x and y intercepts. This one is another drag and drop. Tell me where the graph is increasing. So if this graph is increasing here, you would drag this and set it on top of that, I think. I'm not sure how the drag and drops work. I don't know if you guys are having any problems with those or not. And then this one, what is d of -1? So you find -1 on the x-axis. Tell me the y value. It's a checkbox. You select one of these. Find f of +1. So you find +1 on the x-axis. Read the y value. Let me see what else. Okay, and then this one has relative max and mins. So if it's a relative max, drag it to the relative max box. If it's a relative min, drag it to the relative min box. And you have to sort them all. Does that make sense? Okay. And then this one is just a select all. So I think if you have an end behavior on one side and the other side, you should be checking 2 of these boxes, not 1. You have to check 2 to get it correct. And then this one's asking you for asymptotes. Select all. So don't just tell me one asymptote, tell me these and this one. And same with that. I think that's it. Will we use brackets in the, no, none of my answers had brackets, none of them. All right, good questions, great questions for all of you. Is that enough on the go formative or did somebody have something else? Okay. If you think of something, feel free to email me or we can set up a private Zoom chat together if you need to go through something. You guys have been doing great letting me know what's going on. I know Karan this week has done fantastic. He's gotten back to me several times on the Who Killed Mr. Factor graph. So you guys seem to be doing really, really well. I have to just say, everybody else in the math department is following the alternative learning plans online. And the reason I chose not to is we've already done statistics and sequences in series. And that's what they would have done all this week. And I didn't want to repeat it. So I decided we're going to do our own thing. Now, if I get sick or if I can't be here for you guys, I will probably revert back to the alternative learning plans. But as long as I'm staying healthy, I'm going to go ahead and teach my way. So I just wanted you guys to know the rest of the classes are doing the ALPs and we're doing our own thing. So I hope that's okay with everybody because I like teaching live. All right, everybody, is that it? Are we good? I'm watching the chat room. I'm watching your faces. Kaylee, it's so nice to see you. I hadn't seen you in a while. Kaylee, I have to tell you, I was telling my family about that, name 3 things you use every day and notice I didn't say algebra. Everybody got a great laugh out about it. We're still talking about it. We still make jokes about, what you're not using. All right, guys, that's it for me. I got to get going. So I will see you next week.